the ability to, or the opportunity to access these particular records. You'll be able to find all of them there. For our case, yours is going to be version 7, CCNA Introduction to Network. So there's version 6. Version 6, I'm sure is not in part of your account. I can be very sure about that. But if it is there, yours is not version 6. You're doing Cisco version 7. That's a new program or a new certification course that came from Cisco. Okay, they had changed their content from what we used to call CCNA V6 to V7. That is what we are talking about now. Okay, to V7. Okay, so therefore it means a number of things were removed and a number of things were introduced, moving from version 6 to version 7. Okay, so what you're going to do is version 7, which has 3 modules and a 4th module on security. Okay, so we have introduction to network, then routing and switching as module 2, and then we have enterprise network configuration and security. Okay, so those are the 3 modules you'll do in version 6, and those modules will be done per semester. Then you do your 4th module on security in semester 4. Okay, so the reason why the content were changed from version 6 to 7 is because of improvement, because of new aspects of technology that are coming in. Issues of security, issues of automation of network management, and so many other reasons. So that's why Cisco moved from version 6 to version 7. All these are part of what Cisco offers. All this content you can see from my page here. And many more. We have new items on programming. Okay, we have new courses on programming. But now these are part of what Cisco offers. Okay, if you look at the last item here that I've just highlighted is CCNP routing and switching. CCNP routing and switching. So when you successfully do your CCNA routing and switching, what we loosely call R&S, okay, routing and switching, then you are in a position to go to CCNP, a professional course. So the A here is associate. The A there is associate. The P here is professional. Then there is expert, CCIE. Okay, expert. So that's how the Cisco courses will move from one point to the other. Okay, from one point to the other. Now, so as you do your academy programs, because this is a Cisco academy program, as you do your academy program, what you really need to know, is there are 2 types of certifications. There's certification for the academy programs, and there's what we call the industry certification. There's what we call the industry certification. Okay. So industry certification, once you finish up your academy programs, you can enroll for that exams and be able to do that industry based certification. The advantage of being part of an academy is that depending on your scores, you should be able to score all the subject, or not subject, all the chapters exams, plus end of semester exams. You need to score above 75. If you do that successfully, then you'll qualify for a discount. Okay, you'll qualify for a discount. Okay, so you qualify for a discount as you pay for your industry exams. Okay, so you can be given a discount of up to 70%, and then you only pay for maybe 30% of the total cost to do your exams. But still as well, the academic certificates are still valid. They are recognized within the industry, and you can use them. But apart from the certificates, the most important thing here is the skills. Have you gained the skill sets that is required? That's a very big thing here. You can use the skills to advance your own business, begin your own farm, and so on and so forth. So it's not all about employment that you're looking at. You're looking at a diverse kind of possibilities that you can venture in once you progress with your academic career. Okay. Yes. So once you log in, you'll find those content there. Go to resources, click on the right one. So like yours will be CCNA Introduction to Networks V7. Click on it. You'll find everything that you need there. Packet Tracer, which is a simulation software. I'll introduce it later. You'll find the notes there. You'll find the course outline there. You'll find objectives of the course there, and any other equipment or tools that you might need in the process of studying your CCNA Module 1. Okay, so for those who've not enrolled or who've not managed to enroll, you let me know. You can just maybe share your email with me, or I'll just pick it from the ZDS platform, and then I'll be able to try and enroll you once I'm able to log in on the back end of my account, so that you can validate your usernames and accounts. Then you can be able to download those resources. Okay. Then lastly, on general updates, I wanted to mention that I'll be doing this class maybe for 1.5 hours or so. Then the other 1.5 hours, you go to Netcard and finish up those chapter assignments and the quizzes. Okay, you go and finish up those chapter assignments and quizzes. I'll create discussion forums on this platform where we are now, ZDS, and you can always chat and discuss maybe issues that require an update or something of that nature. Then the course is very wide, very, very wide. It's not like the other courses that the other units that you do. This is very, very wide, extremely very wide, and therefore it means that a lot of effort is required from you to be able to go through. You need to really read quite often if you're interested in pursuing this career further into a different level. Okay. So there are a number of chapters that we look at. Some of them are very basic chapters, like the one I'm going to share now is very basic. Is a chapter that you must have come across. Yeah, any student at this particular point knows all about networks, all knows about basic networks. Okay. So the first chapter is about getting connected. Okay, networks in our lives. What are they about? Okay, what are they supposed to help us do? Okay, so you need to get to learn the effects or issues that relate to networks. Okay, then you need to know some basic terms or definition, types of networks. Some of this content will be covered in your introduction to computers course, so I'll not spend a lot of time on them. You need to look at topologies, still will be captured in your introduction course. And the platform, network platform. Okay, network platform. You need to look at how network influences how people do their day-to-day work, bring your own device issues, video conferencing, collaboration techniques, new components like cloud computing, blockchain, big data, AI, and so on and so forth. Those are issues that really depend on networks to be able to run. You look at issues to do with security, an introduction to why we need routing and switching in the first place. Okay, so that's what chapter 1 is all about. It's basically introductory notes on the basics of what network is supposed to be doing. Okay, so the effects of networks in our daily lives, will not really spend a lot of time into that. The pictures there will speak for itself. It's something that we all know in education, in the banking sector, in the stock exchange market, in the health industry, transport industry. It has really revolutionized how things are being done there. So there are content that we interact with daily. There are things we interact with daily. We are talking about a global world, a small village, no boundaries. You can interact with people thousands of miles away. Okay, so the learning environment has been shifted all through. You can see what we are doing. We are able to adapt with the changing environment or the changing realities in the world, and really be able to fit in, just because of the ability or what networks are able to support. Okay, communication, it has really shifted this. Have been a big way. Really shifted this in a big way. Okay. Our working environment, networks have really supported that through connectivity. We are in a position to do quite a lot. So those are basically application of networks. They are basically application of networks. Will not take a lot of time trying to explain what is there. So the way children do their things, the gaming industry has really shifted. Okay. So these are some of the collaboration tools that we are talking about. The Google Drive for conferencing, we have WebEx, we have Zoom, and so many other tools that are provided there. So this is like a follow-through exercise. You'll find that most of these lecture slides, they have this kind of organization. Okay, after some presentation, then there's a follow-through exercise that you can be able to use to try and check your understanding of the information provided. Okay, when we look at types of networks, it depends on the number of devices that are connected in that network. It also depends on the geographical location or the geographical distance that the connectivity is able to span around. Okay, so we have the small home networks, like what you might be using now. We have the small office, just for one or two people with maybe a printer, a phone, and maybe a laptop. Okay. Then we have the medium to large networks. Most of the time, we'll call them local area networks. Maybe it's a whole building that has a good number of people who are connected, or a good number of devices which are interacting together. Then, of course, we span and go to the wide area network. Okay, wide area network, where we really have millions and millions of computers that are being put together in order to facilitate communication. So where does Cisco come in? Cisco come in to ensure that the connectivity and the security is supported. Okay, so that's why we are learning CCNA, so that going out there, you ensure that this type of networks are supported as far as connectivity is concerned, and the security is also concerned. So in terms of organizations of networks, we can have what we call client server models. Okay, we can have client server models where a client in this case is basically any node, and the word node here will be used frequently in this lecture. Any node. Any node that is only supposed to submit queries. Okay, not much processing is going on within the client. Okay, so it's just supposed to submit queries and then receive answers or support client applications like web browsers and any other application that supports the client. Then the servers are supposed to provide service or information. So servers slightly have, not even slightly, they have a higher processing power. Okay, they have a higher processing power that will allow them deliver services to many clients. Okay, that's the concept that is used in cloud computing. So if you somebody is talking about cloud computing, what we mean is that What we mean is that we access processing power remotely, okay? So issues of storage, issues of processing of queries, we assign it to a remote computer with which is more powerful compared to the ones that we're using. Okay, so that's the structure that we use in computer networks. That's a structure that we'll use in computer networks. Another mode of configuration in this network is peer-to-peer. Okay, there's another style of computer configuration, peer-to-peer. Basically, it's supposed to support a scenario where the client and the server have the same processing power. Okay, so what we do is that the issues of processing, storage, security, and other network services are shared between the two, are shared between the client and the server. So that's what we call a peer-to-peer. So they're in the same level. Okay, they're in the same level. Nothing like you'll submit a query and I'll respond. It's about we share the processing. Okay, we share the storage. We share the security mechanisms. So you can as well take some short notes as I move on. If I'm moving so fast, then you also let me know so that I really know how to control the speed. So on types of networks, they have mentioned them briefly on the previous slides. So I've said configuration are two types. You can do what we call peer-to-peer. peer to peer. Then you can do client to server. You can do client to server. So in terms of networks, we can have three major types of networks: local area network, wide area network, and of course the internet. So that's a bigger picture, the internet. Okay. In each case, as I mentioned, where Cisco comes in each case, there's that configuration that takes place. In each case, there's that configuration that takes place. So there are devices that are involved. There are devices that are involved. There's media that is involved in this connectivity process. So one, there's the devices, there's the media, and then there's the services. So for your network to be complete, you need those three items. For your network to be complete, you need those three items. So whether you're building a local area network, you're building a wide area network, or of course you want to build an internet will build itself once several wide area networks are converged together. Okay, but now within the internet, these devices are also provided for. Okay, these devices are also provided for. Okay, so the network components is explained further, how they're supposed to be grouped together. So we have in terms of devices, we have the end devices. We'll also call them end nodes. As I mentioned, the word node, we're going to use it quite often. So end nodes. So these are going to be the computers that you use at personal level, the phones that you use at personal level, the printers that you use in the office or at your home, the CCTV cameras within the network, all those are going to be end devices. Okay, so for you to be able to send your content, for instance, you're in an office at point A with your laptop, and the printer is at point B, okay, in the office, then you'll need a medium here. This media here device is going to do the transmission. So it can either be in form of another networking device, or it can be in form of a medium. Okay, so that's what we are saying. So this is an end device. This is an end device. In between here, there has to be some communication facilitators that ensure that this communication goes through. So if you look at the diagram that is on the slides, you'll see a local area network, maybe I'll call it A, and you see a local area network B. In between A and B, there's these internetworking devices, okay? These internetworking devices. So we can classify most of the devices in LAN A as end devices, the same to B as end devices. But in between here, we have more than end devices. We have what we call an internetwork kind of communication that is facilitated by different networking devices that I'm going to highlight in the next slide. Okay. Hello? Yes. Hello? Yes, nakupata. No, how will I really help that? The session is still on. You can join. So I don't know. Can you share with me the screenshot that you're able to see from your end? Yes, because there's a button there that you need to click. It's written, I've named it Chapter 1. Yes, you check and then you share with me what you can be able to see. Okay. So if you know somebody who is stranded, a classmate, and is not able to join, you can extend a helping hand to that person. Okay. You can help the person be able to join through. Okay, so next is on the internet working devices. We can also call them intermediary devices. That the role is to ensure there's a connection. The role is to ensure that there is connection. Okay. So these devices are supposed to ensure that there's a connection. So examples that we have are switches. There's wireless access point. We call them APs. We have the routers, and then we have the firewalls. So all these are examples of what you can classify as networking, internet working devices or intermediary devices. So some of the functions of these devices, just on a brief, because there's deep functions that we look at. One is to work on the signal, retransmit, regenerate the signals within the network. They also need to know the routes or the paths or the existing pathways within the network. Remember, in a network, those connectivities that are present are supposed to be our paths. So if I want to send content from device A or person A to person C, then there has to be a route, there has to be a path to be followed. Then they're also supposed to be checking on communication errors or failures. They're supposed to be checking on communication errors or failures, so that if content is sent and it doesn't go through properly, then either a retransmission is done or the all communication is broken down and a new one initiated. Okay, so that is still part of the role of internetworking devices. They are supposed to ensure that that particular process is well taken care of. Okay, so as I mentioned, if I pause a little bit, it's your time to take your short notes if you are taking up those notes. So to properly ensure the network is complete, you need what we call the network media. You need to connect your network. You need to connect your network. You need to connect your network. So confirm the screen that you are able to see. There's somebody telling me that the screen is not, the slide on the screen is not. So kindly confirm you can be able to see the slide. If not, refresh your page. Okay, I'm trying to help one of your colleagues who is not able to view anything. Okay, so I was saying that for you to complete your network configuration, or for you to complete your network for connection, then you need the cables, or you need the media. So currently where the technology is, we have 3 major media channels. We have 3 major media channels that we can use in trying to complete our communication process. So we have the copper. Those are basically the wires and the cables. When we open up for physical classes, then I will be able to show this content in a lab. We have the fiber that has really taken shape as far as communication is concerned. And then we have the wireless, where we have the access points. Okay. So wireless can be in so many forms: infrared technology, radio technology. Of course, radio is the one that is quite often used. The radio technology, and so many other technologies that informs wireless transmission or communication. You can go and check types of wireless transmission. Okay, how do they impact the construction of a network? How do they impact construction of a network? So they're very, very important technology that has really changed how we communicate, from your phone to the physical radio to the TVs and so on and so forth. So the wireless transmission also include even the satellites communication. Okay, so you can just have a look at the types of wireless communications that are currently in use. Okay. Yeah, so you put network media together, you put the internetworking devices or the intermediary, and then you put up the end nodes, then your network should look like it's ready to go. Okay, so in terms of the paperwork presentation, then your network should be ready. But now what remains is the connecting of those particular devices and performing the configurations of those devices there. Okay, so whether you are constructing a local area network, just a small network for a single building, or you are doing a wide area network, maybe 2 or 3 buildings, then all those 3 items that we've mentioned are major players in that particular process. Okay, so Cisco as a company is a major player in provision of the intermediary devices that I've mentioned there. Okay, is a major player in provision of those devices. Other players also exist. Like for instance, we have Huawei that also provide those type of devices. Okay. So Huawei also provide those devices. And therefore it means there are also programs similar to this that are packaged together by the Huawei technologies. Okay. So depending on what you really want to learn, you can choose. But now the concepts are the same. The only thing that is difference between the two is that the what we call the syntax. It's like, for instance, trying to give a speech in English or give a speech in Kiswahili. The same speech can be translated. So that's the same concept here. Okay. So what you do in Cisco devices, you can translate it to what Huawei devices understand, and you're still able to move to construct a network using those devices. Okay. So Cisco, Huawei, HP, those are major vendors in this industry. Alcatel, still part of this industry. Okay. So depending on the country and specifically the continent where you are, you'll experience different types of devices. Okay, you'll experience different types of devices. So for us in Kenya, Cisco has been on the forefront in terms of those devices provision, followed by Huawei and other players. Okay, so you check on job applications. If they need a network technician or a network engineer, they'll always mention either Huawei or Cisco. So that's why we choose one of them as an academy program for you guys. Okay, so moving, putting up the network together, we also have specific elements within the devices themselves that will help us in the connection. Okay, so you can see the grouping that has been done there. You can see the groupings that has been done here. Okay, you can see the groupings that have been done there. So if you cannot be able to see well, you can let me know so that I see how to zoom out my slides. Okay, so we have a few ton. So as I mentioned, elements that are also very important within the networking devices, okay, or even the computers themselves, okay. They are hardware processes that are very important, okay. So they are majorly three, okay. They are majorly three. Network interface card, that is for the for your computers, for your desktop, and so on and so forth. They really help your computer to be able to do translation. Okay, so it's the point of connectivity or point of entry for network connectivity. Then we have the ports. A port is basically an entry or an exit point for a signal. Okay, so if you're using a laptop now and you check your laptop, it has ports. Some of the ports that are there are for flash disk or what we call the USB ports. Other ports that are there for VGA, maybe for connecting your laptop or your desktop to a projector. Then we also have a very important port there for network, what we call the RJ45 port or the LAN port. Okay, so that is what you'll be able to use in connection or in trying to introduce your computer into a network, the physical port. Okay, the physical port. The word interface will be used almost interchangeably with the physical port. Remember, there are logical ports that we'll study maybe towards the end of semester 4 or something like that. Okay, so we are talking about the physical, the one that you can see. So we have logical ports that you cannot see. They are numbers. Okay, they are numbers, and they're very important in networks. Okay, so logical ports. So that's why we say physical ports and the logical ports. And the logical ports, because they will be really of help to us moving forward. So for now, get to know what a physical port is and get to know a network interface card. Very, very important elements in network communication. So we have some representation there. So we have what we call a physical topology. Topology is basically organization, is an organization. So we have physical organization, and then we have the logical organization. Just the same way you will do the architectural design, okay? There is what somebody can be able to see as a house that was built, but now then there's that drawing that represents the actual house in working. Okay, so what is being presented that you can be able to view and see, and then there's that presentation of the workability, what is working within that particular structure. So in networks, physical is what you'll be able to see. Okay? You go into a room and you see the way people are seated. There's that office A there, there's office B, okay? So there's office B there, there's office C there, then you see a switch somewhere here, okay? You see a switch somewhere here. Now this connection you see here physically, those are what we call the physical topology. Those are what we call the physical topology. But you as an expert, when you are doing this programming or you are trying to configure this network, your configuration does not follow this physical structure, okay? You don't see A, B, and C has been connected to the switch in this particular order. Okay, so that's what we'll call a logical connection. So this is the configuration, but now this is the image on the ground, or the picture of what you can be able to see. So in networks, most of the time you'll be struggling with the logical. The physical, you just do it because there has to be some level of organization in your work. Okay, you just have to do some smart and networking. So types of networks, once again, have been mentioned there. You can just read through. I think I'd mentioned what they entails. You can just read through and have a look at them. Okay, so those are technologies that you can use for businesses and corporates. And then what is provided here is a topology for maybe packet tracer. I'll introduce packet tracer maybe a little bit later. Okay, that's what is provided here. What I'll request that you do, you can have a look at how digital subscriber lines work. You go YouTube, check a video on how DSL work. Okay, very, very important that you really know how the actual process go. Also look at the in details dedicated list lines, how they work, so that you relate them with actual scenarios on the ground, what you've seen before. Okay, you relate them with actual scenarios on the ground. Will be really of helpful to you. Okay, so I've mentioned this is a packet tracer topology that really represent how a network should look like. Represent how a network should look like. So it's a simulation process, okay? CCNA through packet tracer is a simulated process, a process that reflect what happens in the real world, but in a simulated environment. Okay, so this is how the network should look like. That's how the network should look like. Okay, so the next one is network as a platform. Network as a platform. So apart from the technologies that we've talked about, then we really need to know what it is that network offers. What it is that the network offers. So we look back and see how networks were organized. We look back and see how networks were organized. So each service would be acquired separately. You would acquire a telecom line for telephone. You acquire a different line for networks. You acquire a different line for broadcast, for maybe your TV, or so on and so forth. But now, what has happened with the current trends in networks? Signals are put together, and I'm sure this is something that is not new to you. All those who have managed to interact with Jamii, with Zuku, you know that one signal comes with 3 different services. Okay, so the communication comes with a telephone service, or a communication service comes with a television service, and comes with the bundles or the bandwidth connectivity. Okay, so that's what has changed from what used to happen before to where we are at this particular point. So the diagram there says that that's about 30 years ago, when networks used to look like the way they are on that particular slide. But of late, we have technologies that carry communication signals using different set of rules and standards. Okay, so what we have nowadays is bundle all this together, carry them as one, and provide the service to the user. That's what we call converging network. That's what we call converging network. Okay, so we carry everything together. We can do voice, data, and video based on the same network infrastructure. So those are part of the changes that have evolved up to this particular point. So as I mentioned, we'll always have research gaps. You can these scenarios, I'll always post them on our discussion forums on the ZDS portal, and you can always have a look at them and provide your thought process, what you think can be done, or what you think the scenario should have been addressed better. Okay, so always post them there. So you need to look at the convergence or converged services that are available to you as a person. Okay, converged services that are available to you as a person. You also need to understand local internet service providers that offer such services, those converged services. And in your environment, you look at a company or a corporate that is using those technologies to serve their clients. Okay. Yeah, so as I've mentioned, I'll always put this content on our platform there so that we share ideas on what you're able to follow through. So what we've mentioned up there, the client server, the peer-to-peer, and all those technologies that we provided there, a network is supposed to provide 4 very important services. Okay, any network should underline all those 4 services as part of what they need to provide. So each and every client will want a very stable connectivity, a very reliable network. Okay, and we say if a network is reliable, then it should ensure that it's fault tolerance. If a fault occurs, there are mechanisms that can be used to continue with provision of the service despite the fault being rectified. That's what we call fault tolerance. A concept we'll look at later in networks as redundancy. Okay, redundancy of links, so that several links are provided for to support the same service. So if one goes down, the other one can still be able to work. Quality of service, that's mandatory. The service provided, if it is voice, if video, it has to be to the standard that is required. Security, mandatory. Security of the services, security of data are very, very important in reliable networks. And scalability, ability of a network to expand. Companies will always grow. Companies will merge with other companies and form new companies. You don't need a network that is not able to accommodate the incoming or new found partnerships within the business. You don't have to start from zero or from foundation to build a new network to accommodate that. So your network has to be very, very scalable. You can expand it, and it can be able to take in different modes of business partnerships. So those are 4 characteristics of what a reliable network architecture should look like. Yeah, I've explained all those content. You can have a look at them in details. Expansion is about scalable networks. How well can we expand it? Quality of service, very important. We have even standards that define this quality of service, each for voice, for video, and for data. We have standards that defines them. In your advanced network career, then you'll be able to learn standards to implement in order to ensure that the traffics are classified. Okay, classification of traffic is part of what QoS or quality of service demands. So security, I've talked about that one. We talk about confidentiality, we talk about integrity, and we talk about availability of these services. Are they available in timely manner? Is there integrity? Are we consuming data that has not been altered? And confidentiality. Only the people who are permission to have access to that data are the ones that are really accessing the data. So this is what security is all about. And I've said that there are standards that define these components of security as well. So we'll be able to see them going forward, how you're supposed to put them together. So now you can have a look at these ones maybe on your own, the changing trends in networking. You can have a look at them at your own time, including the ones that we are doing now. Okay, the online classes, these are changing trends. These are trends that never used to be there before. There are things that are coming in because of the the ability of networks to support different services. So there's bring your own device, we have video collaborations, we have video communications, cloud computing. Yes, Mr. Coco. Hello? Hello? Yes. Hey, why? How are you? What year class? Okay. Okay, so those are trends that are coming as a result of the networking technologies. So they are explained further what they actually mean. Bring your own device basically mean what happens in organizations currently. Everybody comes with his own laptop, phones, and so on, and plug into the network. Okay, so they have their own challenges, they have their own disadvantages, and that need to be addressed. So as a network technician, you really need to have a way on how you're going to capture the new technologies, either on the positive side or the negative side, but to ensure that still your network is stable. Okay, so it's basically more explanation on that. I think I talked about online collaborations. I've talked about video classroom. I've talked about cloud computing, accessing the computing power remotely. Okay. Yeah, so you can have a look at those trends at your own time. What I wanted us to finish up with is because we are talking about Cisco, it's a rule of thumb that, or you mention to somebody what Cisco is, really, you know what you're talking about. So Cisco is a networking company that has grown to the level of an international company. Okay, and their main agenda is provision of interconnectivity devices, and they do that through security courses, they do that through routing and switching courses, they do that through, they've introduced that on the aspect of programming, and that's why they changed their syllabus from V6 to V7, version 6 to version 7. Okay, so this is the pillar of Cisco. This is the pillar of Cisco. So entry is the academy. You do your first certificate, you become associate in the industry. You do your second certificate, you become a professional. You do your next certificate, you become an expert. And then now, of course, once you have become an expert, you build to become an architect or a consultant. So I've mentioned that at the entry level, you are supposed to be under an academy, like what you've done now. Then I've mentioned that if you score 75% in all your exams within the net card and within ZDS, then you get as much as 70% of a discount. Then you can sit for your associate program to become Cisco Certified Network Associate. Okay, Cisco Certified Network Associate. So the ones that are appearing here, are the exams that you're supposed to be doing. Although the names have been changed with the new syllabus that has been introduced. Okay, but now you can see the content. This content still remain the same. So you'll just sit for one exam if you are to do your industry certification, Cisco CCNA. Okay. So that is what Cisco certification is all about, and that's the pillar, or that's the career path in networks and telecommunication. Okay. So unless there's a question, you let me know. But before maybe you ask a question, I would love to know, DIT students, any DIT student who is here? DIT student? Any other person apart from Donna who do not have an account? Any other person apart from Donna who do not have an account? Okay, so if there's any query, if there's any conflicting issues on the timetable, you let me know. Yes? Yeah, so if there's any conflicting issues on the timetable, you let me know. Okay. Otherwise, my number is on the platform. You can call me maybe or WhatsApp if there's something that I need to address. Okay. Because it's a virtual learning, you really need to take it as a personal initiative to interact with me if you have an issue, because I'll not be able to know if you have an issue or not, and I'll not be able to know whether what I've taught you've understood or not. So it's you to communicate quite often so that we moderate what we are doing. If you have a problem with the net card, you let me know also so that I can work on it. Otherwise, we'll stop that particular point. I said I'll always do 1.5 hours. The rest of the 1.5 hours, go to your net card, and do those chapter exams. Like for instance, now you have the ability to do chapter 1 exams. You can try the quizzes, or you can just do the exams if you feel comfortable with that. Okay, so you have about an hour to follow up on that. Okay, yes, there's no question, then you are free to log out. If there's no question, you are free to log out. Okay, thank you. Stay safe. Let's meet next week. For DCS and DSC, we can meet for analog electronics on Friday.